In this problem, again, I'm being asked to use analytic methods. That means not a graph. I'm looking for the extreme values of the function over the interval that they gave me. And I'm supposed to identify critical points that are not stationary points. So this is the interval that they gave me, and I'm going to write it in interval notation, -3, 1, parentheses, because notice that the 1 is not included in this graph. So even though they gave me an interval, I still want to check the domain of this function. And, well, I don't see any denominators with variables in them. I see a radical sign, because the root here means a radical sign, but it's an odd index, so I'm not worried about that. And I'm not worried about logarithms. There's no logarithms. So the domain of this function, were it not for this restriction over here, would be -infinity to infinity. So that's a good thing to know. I'm not exactly sure what the end behavior would look like. I have an odd index root, which frequently looks like that, but it's squared, so I'm not exactly sure what it's going to look like. I'm not going to worry about it till maybe the end of the problem. So let's get to work and find the derivative of this. We want to find f prime of x. Well, it seems like a pretty straightforward power rule, so I'm going to call it 2/5 x to the -3/5. And I think I'm going to rewrite that just because sometimes I like to look at it one way, sometimes I like to look at it another way. But it's 2/5 times the 5th root of x cubed. So if I'm looking at the denominator here, I can see, well, if x equals 0, this function is going to be undefined. Or rather I should say the derivative is going to be undefined. The function up here would be fine if x equals 0, but the derivative is undefined at 0. So if the derivative doesn't exist at a particular point that is within the interval, that means I have a critical point. So x equals 0, that is a critical point. And since if x equals 0, the derivative does not equal 0, it is not stationary. As you remember, to be stationary, the derivative has to be 0. As far as I can tell, then, this is my only critical point in the function. So this is one possibility for an extreme value. The other possibilities are my endpoints, -3 and 1. So all three of those are candidates for being extreme values. So let's evaluate them. Let's first look at f of 0. Well, f of 0, I plug 0 in right here, that's going to be 0. So f of 0 equals 0. F of -3 equals, well, let's plug it into the function, that would be -3 to the 2/5. So that's going to be, well, -3 squared is 9, so it's going to be the 5th root of 9. I think I'll leave it like that for a minute. And let's evaluate f of 1. Remember, I'm putting this into the function, not into the derivative. The derivative has already served its purpose by indicating to me the critical point. F of 1 is 1 to the 2/5, so that's equal to 1. So I can only have extrema at critical points and at endpoints. And so, and I made another mistake here, because 1 is not an endpoint, because it's not included in the interval that I'm analyzing. So even though this isn't going to be an extrema anyways, I shouldn't even be looking at it. It is not a critical point. So my critical points are, I have a critical point at 0, and I have an end point at -3. This is clearly a number larger than 0. So this right here is a minimum, and this right here is a maximum. So this is my answer right here. My answer right here is the 1 point, the minimum is 0, 0, and the maximum is -3, the 5th root of 9. I have one critical point, and it is not stationary. So those are the answers to this problem. Good point in this problem was recognizing that I really didn't need to do f of 1 because it was not an end point. I put the graph here on Desmos because even though we're doing this analytically, I probably want to check my work with the graph if I can, and I can see that this is clearly a maximum right there, and that point exists. This other point right here is one undefined, so there is no endpoint there, just so you can kind of see that. And then this point down here, which was a critical point but not stationary, was a cusp. So I kind of could have figured that out because I knew that the domain of the function over any interval was -∞ to infinity. I knew that there were no holes in that because my domain was all real numbers. Well, if my domain is all real numbers and I have a critical point that is not a stationary point, that pretty much means it's going to be a cusp or a corner. Because if it was a vertical asymptote, it wouldn't be part of the domain. If it were a hole, it wouldn't be part of the domain. So that kind of told me right there that that was going to be a cusp or a corner. The other thing I would just like to point out here is that you can't see it because I can't draw in here, but let's say that this had kind of gone way out over here. You can kind of see the arrow. And that had been like higher than this point right here. Well, in that case, I would not have a maximum because that point way over here, that point way over here would have been undefined because it was an endpoint, it was an open endpoint. So I would not have had a maximum for this graph. I would have just had the minimum right there at 0. There would not have been a point that was the maximum.